You know, in engineering, one of the biggest challenges, and it's been around forever, is trying to get perfectly smooth, stable, reliable linear motion. It sounds simple, right? Just moving something from point A to point B. But whether you're building a high-speed robot or a super sensitive piece of medical gear, doing it without any wobble, without any friction, well, that's where things get tricky. So that really gets us to the big question. What is the secret? When you have forces pushing from all different directions, sideways, up, down, maybe even twisting forces all at once, how on earth do you build a system that just glides effortlessly every single time? What's the secret sauce?
Well, a big part of the answer might just be looking at this little guy right here. This is the MLGX25 Multi-Roller Linear Guide. And yeah, at first glance, it looks like a really well-made, sleek piece of hardware. But the real genius here, the real innovation, isn't what you can see on the outside. It's all about what's going on inside.
And that brings us right to the heart of this thing, the dual X structure. This is really where the magic happens. So let's peel back the layers and take a look at what dual X actually means. So the dual X structure is basically a very clever, patented way of arranging the rollers inside the guide. The whole idea, the entire point of this design, is to fight back against forces from multiple directions at the exact same time. It's all about making sure that movement stays rock solid, no matter how the load shifts around. And this slide just shows you that difference perfectly. I mean, look on the left, you see this clean, simple, unassuming block. But then you look on the right, and you get a peek at what's really going on under the hood. This is no simple track with some ball bearings rolling around. It is a seriously engineered system. Okay, and this diagram shows exactly how it works. See how the rollers are set at these opposing 45-degree angles? They form a kind of X shape. So think about it. When a force pushes straight down, it gets met by that angled resistance. When a force pushes from the side, guess what? It also gets met by angled resistance. The load gets spread out perfectly across all these different contact points, and that is the key to its incredible stability. So what do you actually get from all this clever design work? Well, first off, you get super smooth movement, even when there's a twisting force, what we call a moment load. Second, because it uses rollers instead of balls, you don't get something called ball creep, which makes it absolutely perfect for anything driven by a motor. It's also preloaded, which is just a fancy way of saying it's factory tightened, so there's zero rattle or wobble. And finally, you can pretty much mount this thing in any direction, and it's going to perform just as well. All right, that all sounds fantastic on paper, but how does it actually hold up in the real world? Let's dive into Section 2 and check out some of the hard numbers. 500,000. Yeah, that's not a typo. That is the number of cycles this guide went through in a private endurance test. And to give you some perspective, each one of those cycles was a 200-millimeter round trip. We're not just talking about being smooth, we're talking about being durable and reliable for the long haul. That means less downtime and lower maintenance costs for whatever machine it's in. Okay, what about pure strength? Well, the MLGX25 can handle an operating load of up to 27 pounds, or 120 newtons. And here's the kicker. Because of that dual X design we just looked at, it can handle that full 27 pounds whether the force is pushing down on it or pushing from the side. That is a huge, huge deal when you're designing something. And this little table breaks it down nicely. You can see right there. The operating load for horizontal and vertical forces is basically identical at 26.8 pounds. Plus, it can take on a pretty hefty twisting moment of over 21 pound-inches. These are the kinds of specs that show you the design really works when the pressure's on. So, with that kind of performance, where does a component like this actually show up? Let's take a look at some of the real-world applications where this thing shines. Components like the MLGX25 are really the unsung heroes in fields where you have absolutely zero room for error. We're talking about high-stakes industries where precision and reliability aren't just nice features, they are non-negotiable requirements. And that brings us to a pretty impressive list of where these are used. You know, think about automated machinery that has to repeat the same motion millions of times, or the incredibly precise movements inside medical equipment like scanners. Analytical instruments that measure things down to the micron, the rugged guides and machine tools, even the smooth, satisfying slide of a drawer in high-end food equipment or kiosks. All of these depend on this kind of hidden technology to work perfectly. So when you put all of that together, the clever design, the solid performance, and all those different applications, you start to get a really clear picture of what this is all about. It's about having a precision advantage. And really, that's the promise of the MLGX25 and its dual X structure. It's about elevating a system's performance, taking it to the next level. And it does that by solving a really fundamental engineering problem, handling complex loads with a design that is simple, elegant, and just incredibly effective.
So I'll leave you with this final thought. We've seen how a really smart internal design can solve a huge problem. Now that you know what's under the hood, it's worth asking yourself, where could this kind of stable, reliable, precision motion make a real difference in your next project?